You would be amazed at some of the stuff I've seen, like programs that were built in the 60s or in a language named after a dude who has passed away 10 years ago and no one knows how to maintain it anymore. And our tools just seem to work on all of it, which is phenomenal. And so that's kind of where Tricentis started to play, is big companies with big QA problems that need really, really comprehensive solutions to them.
Hi, my name is Demetri Panici, and I'm a content creator, agency owner, and AI enthusiast. You're listening to the AI Agents Podcast, brought to you by Jotform, and featuring our very own CEO and founder, Ida Tank. This is the show where artificial intelligence meets innovation, productivity, and the tools shaping the future of work. Enjoy the show. Hello, my name is Demetri, and welcome back to another episode of the AI Agents Podcast. In this episode, we are interviewing David Colwell from Tricentis. How are you doing, David?
Doing great today. How are you, Demetri?
Doing awesome. We're really excited to have you on. It's been good chatting with you in the pre-screen. We were just nerding out about a new release that just came out. Well, as we were recording this, about an hour previous to the start of our call, Claude 4.0 dropped. So I was just learning a little bit about that from you, and that was fun. I'm a huge
AI
fan
nerd
of
came
releases.
out.
Yeah, the AI nerd came out. We forgot we were going to record a podcast. So just to get started, I want to learn a little bit more about yourself and Tricentis.
Yeah, so a little bit about me. I came from the world of quality assurance. Development was more of a hobby for me than a primary job. So I grew up in QA, doing quality assurance for organizations, consulting for organizations, building QA practices. And the whole time it kind of struck me that QA was in need of really good tooling. And so I started using things like Selenium, automated tooling, but they always felt a little weird. Like we were asking people that didn't code for a living to code for their living. And so an opportunity came up at Tricentis in the Sydney office, and they said, "Hey, do you want to come over and join us?" And so jumped over onto that side of the fence. Tricentis is the leader in QA tooling. They offer tooling for managing QA, optimizing practices, tracking code through to tests, automating literally anything. You would be amazed at some of the stuff I've seen, like programs that were built in the 60s or in a language named after a dude who has passed away 10 years ago and no one knows how to maintain it anymore. And our tools just seem to work on all of it, which is phenomenal. And so that's kind of where Tricentis started to play, is big companies with big QA problems that need really, really comprehensive solutions to them. So I won't rattle through our customer list. There's a ton of them. You can check it out on the website, which is tricentis.com. But my role within Tricentis, I actually kind of started out in the solution architecture side of it, which I was sort of trying my hand in more of the customer-facing side of the role after having spent all my days in technology and back of house. Lasted about 2 years, built the APAC division of the solution architects, and then the R&D side got tired of me suggesting all the cool new things we could do with the product and said, "Hey, how about you come and build them instead?" And so I ended up back in the tech side. I built our AI department at Tricentis in 2018. The goal of it was always, hey, there's a lot of labor in quality assurance that's not a ton of fun. Things like, I've got a test case and it runs and then it breaks because the developers decided to refactor the front end code. And now the business users are saying, "I thought you said this thing was going to save us time and now it's breaking. What gives?" And so I thought all this labor is just a really good opportunity to apply AI to. See if we can make AI approximate good solutions. We started out writing patents and designing neural networks for object detection and regression networks and all the things that used to be called AI prior to 2023. And then, the generative AI things, it was actually kind of funny. We started in generative AI in 2019, I think.
2019. Wow.
Yeah. You may not know this, but generative AI started in 2017. So that was the first transformer models. Back then, there was some kind of Sesame Street naming convention. So the first models were things like BERT. And that was a bidirectionally encoded representational transformer, I think. There's always a way of making the acronym into a word and making it humorous. Like the first image detection models that we used were called YOLO models, which for those of you that were on the internet circa
That's funny.
2017. You'll find it very funny. For everyone else, they'll be like, "What the hell are you talking about?" But yes, so putting aside the weird humor of data scientists, we were looking at these models because everyone was excited about their ability to translate natural language. And translating natural language into something structured is a large part of what QA is, because you have to take a requirement written by a human, and humans aren't algorithms. They don't structure things in predictable ways with deterministic, X, Y, Z formats, even though we tried with things like BDD. We said, you'll write in given, when, then. And then business people said, how about we don't? And you try to translate it into that for us. So attempts to change humanity did not work. So we thought maybe we can use these transformers to change humanity for us, like just understand what the human means. The answer, in very short, was no, it didn't work because the early transformer models were very large for the time, which is hilarious now. We say, oh, it was 1.5 billion parameters. Well, that's a baby model now. Back then, when GPUs, with 16 gigabytes of memory were a big deal, that was a big model. But also, they were kind of rubbish. Like they understood language and they could write words. But if there's a hilarious video online actually about one of the early GPT clones called Botnik writing a chapter of a Harry Potter novel. And it is pure comedy gold, but it was celebrated by the machine learning community because we're like, wow, it knew how to understand the concept of Harry Potter and writing and a novel. Like it knitted all that together. But to everyone else, they looked at it and it said, well, the first sentence was, Ron was going to be spiders. He just was. There was nothing Harry could do about it. You're like,
He was going
oh,
to be spiders. Is that what it said?
he was going to be spiders, yes. Not that he would eat them or look at them. He was rapidly becoming an arachnid, apparently. So
That's incredible.
I know. It actually, to this day, is the funniest chapter of Harry Potter that I've ever read. At one point, it gets kind of down a rabbit hole and it thinks that the Death Eaters are a form of middle management. And they go up to the top of the castle and start having a meeting, when at the end of the meeting, they like congratulate each other and, oh, well done. And so you're just reading this and you're like, I can see how this flows as language, but as a work product, I find it wanting. So that was kind of the story with testing. We give it requirements and say, turn these into test cases, and it would just start rambling on about what test cases are, and then just probably insert spiders at some point. So not super useful. And GPT-3, not 3.5, the Da Vinci ones that were kind of completions, they were a big step forward for us.
Yeah.
They were the first point where we were tricked into thinking that this could do the job. Because it was a lot better at writing, but it didn't actually produce good work product. It was but it was now a lot harder to tell that it wasn't good work product because it sounded a lot more like it was. It like used all the right terms and it kind of threw things in there that, like, I'm going to do some functional tests and some regression tests and some whatever. And then you'd go, yeah, this looks great. And we all were kind of super hyped about it. But when we looked at the test cases and we started applying actual rigorous thinking to it, none of them were actually useful. So, like, all right, so what's the net effect? And we worked out that the net effect of generative AI in those early days was a negative productivity, because you spend more time reviewing the output than you would have to write it yourself. So we had this, because the outcome that we're after is somewhat exact. It's not like it's not like we're writing a novel where you can just kind of edit it along the way and correct it bit by bit. You ended up needing to know all of the test cases that you needed on one hand and all of the test cases that it wrote on the other hand in order to figure out if it missed anything. And so that's double the work because you need to write the output before you can review the output. So we kind of parked that for a while and lent into agents. And we started building the first agents with ChatGPT 3.5. I think it was version 11.02, the first version that could use tools. And we gave it access to one of our AI screen not recording, but you'll get the idea. It's kind of like a screen recording and acting software that uses an
Yeah.
object detection model.
Yeah.
It's called Vision AI. There's a whole post about it on our blog to see how it works. And we allowed ChatGPT 3.5 to just kind of steer the model, saying, I want to click on that item. I want to look at this thing. I want to select from that drop down. And it was okay, but it was another kind of sugar hit where we went, this is it. We've solved it. Humans don't need to do, test automation anymore. The AI can craft it for us. And we figured out that no, it can't. It just kind of gets stuck in circles. It does pointless actions. The test it generates is really full of noise. And when you give it to a human, they spend a long time going through and cleaning up the work that the AI did, because again, the output we're after is a bit more precise. And so we kind of stopped investing too much into that and went down the same path as everyone else with assistive AI, shipping things like copilots. And they're okay. Like, they help users use our products and answer questions. They provide a minor productivity uplift, which definitely pays for itself, but isn't like game changing. But between that, there was a lot of shift in models. And the biggest shift was O1.
Yes.
Now, out of all those, everyone kind of remembers DeepSeek and forgets O1, but like O1 and DeepSeek are kind of the same thing. They're instances of the first reasoning models. And the reason that that was important to us is because reasoning models are kind of a way of the AI reflecting on its work as a trained component, rather than us trying to force it with things like what's that old thing that we used to do where you'd force the AI to reason through? It was a chain of thought
Yeah.
prompting.
Yeah.
Reasoning's like built-in chain of thought prompting that works 10 times better. So we
Agreed.
went down the O1 models. Yes, and that's why they did it. We went down the O1 models, and finally we could actually start building and shipping agents, things that would actually do the work that the human would do, check their output, be more precise, be more productive. And so we're kind of in this world where now the AI is caught up to where we want to be. And now the AI is racing ahead. And every day we're kind of like, all right, what can we do? We need to adapt more things. Oh, MCP's appeared. Where did that come from? Quick, put that in the products. Oh, wait, we don't need it. No, wait, yes, we do. It's kind of this iteration of trying to figure out which parts of the AI buzz cycle are actually durable components that are going to stick around for the long term and solve problems that we actually have, and which ones are the here today, gone tomorrow noise that gets wiped away when Anthropic or OpenAI decide that they're going to ship a protocol for it. So that's kind of the world where we live at the moment. Yeah, and that's probably more than you wanted to know about my background.
That was a good starting point. I was just letting you cook there for a minute. You brought us through what you guys are doing, and also what the history of, I feel like, AI has been through, so it wasn't, it was definitely useful for a lot of us, because I wasn't actually aware of the actual year when these models started to be, be in their earliest infancies. Like 2017 was not a number that came to mind immediately. So it's pretty incredible when you think about it. We were actually somehow almost 8 full years then into generative AI, right? Based on that.
Yeah, we are. And there's this interesting point in time in generative AI where we aren't entirely sure what happened. It's called some people call it the emergent point. It's where the AI started to display emergent behavior. So things that we didn't expect in the AI, like it responding with emotion, just started to appear. And the reason that was unexpected is the models got a lot bigger. This actually was the Da Vinci model was 175 billion parameters from memory, which was about 10 times the size of the next biggest model.
Yeah.
But it had been kind of a truism of machine learning up to that date that model size was a diminishing return. So you would see it sort of rising and then flattening out asymptotically. And that was true of computer vision models, and it had so far been true of transformers up to that point, where the accuracy and the quality that you get out of them diminished with the not went down, but the increase in quality was not linearly proportional to the amount of parameters that you had in it.
Yeah, I would imagine.
But then it was with GPT 3.5. There was almost this unknown jump in size. Like when you went all the way up to these huge models, suddenly it was a lot better. Like we expected it to be slightly better because you're getting these diminishing returns. But instead of being slightly better, it was just a lot better. And so no one was quite sure what caused that jump at the time. There's some theories on it now that maybe it had hit space limitations in the AI, and lots of words for people saying, I don't know, but I've got psychological terms that make it sound like I do. But then from there was like this arms race with make model bigger, because model bigger is going to result in just exponentially better performance. That also kind of stopped being true. We're starting to see those sort of asymptotes again with the giant models like GPT 4.5 and I don't know, when's GPT-5 coming out, OpenAI? How big is that going to be? They stopped publishing it. But as humans, we've started to see less of the giant leaps that we saw between GPT 3.5 and GPT 4, which was a massive leap in quality. And then when you look at GPT 4 to GPT 4.0, it's a little bit harder to tell. When you skip like 5 model versions and say like GPT 4.0 to maybe O3, then you're looking at massive leaps. But it's more coming in those like reasoning jumps in between. So yeah, the history of generative AI is a weird one because I think as humans, we've kind of stopped understanding what's happening in the machine, and we're just sort of along for the ride now.
Oh, I think that's a totally fair point. I'm not sure if you've seen, there's an extra interesting chart out there that actually breaks down the quote intellect or IQ, right,
Mm.
of the AI. Have you seen the year-over-year change?
I haven't seen the year-over-year change. I saw how like it's gone to Superintelligent, I think, with was it
Three.
O1 or O3?
Oh, three.
So
Oh,
3.
three, I think, was the first point in where it was I can maybe find it. It was on Twitter. Well, whatever, whatever we want to call that platform, right? So
Yeah,
it hit
saying it was on
on
X just sounds weird,
yeah,
doesn't
yeah, it's just sound on X makes it sound like I'm saying a variable.
it?
So right, yeah,
A bunch of math professors are very
yeah.
angry right now.
Now this is interesting. So this is the increase here, and I have a question based off of this. So let me make this a two-parter. Okay.
Yeah.
Part one, I find it incredible that we've hit O3 is at 136 Mensa IQ score. That's insane. That's number one. Number two is last year we were actually in the realm of these like 4.0 models and stuff like that. And Claude, I think, was maybe actually leading the charge at one point here. Was only really at like a 70 IQ. Like that's a mic drop, in my
Hmm.
opinion. Because I was looking at it, was 70 to 80 IQ is kind of the range of what was like better models a year ago. And I looked at it and just went, huh? You know, like, so what are you seeing on your side intangibly at the company that is coming out of this leap in intelligence that I feel like to the layperson, yeah, I'm in a bubble, so I see it and I work with it every day. But how would you describe that to the average person? Like what you're getting out of this incredible improvement?
So I think the easiest way to understand why it is hard to see the progress unless you're giving it a discrete and measurable task is
Mm,
imagine you're talking to someone of normal IQ. Like you're talking to a person in like the 90s to hundreds kind of range. So I know it's not dead on average, but someone in that range,
of course.
and you're asking them questions, you're conversing, you're doing a lot of what you do with AI at the moment. Hey, help me write this thing, and they're writing you content. And then you go talk to someone of Mensa level IQ, and you say, hey, Calvin, help me write this thing, and they help you write that thing. If the task is sort of not an expert task and it's imprecise, then you're probably not going to perceive that as the giant gap that it is, because you'll get decent results out of both. One might be perfect and the other one will be near perfect, but the gap is small. you only start to notice it when you give it incredibly difficult tasks. And I think what's making us feel like IQ is the smartest dumb person I know or the dumbest smart person I know is you can give it a task and be absolutely blown away. For example, in coding, you might say, oh, I've got this really difficult to optimize thing. Can you go through and find the areas where there's a memory leak and then create a new vector map to improve the speed of this? And you're like, wow, that was phenomenal. But then at the same time, you're like, hey, I need you to help me plan a trip to go around. No, I'm in Austin now. I'm not Sydney anymore, so I don't know the landscapes well. But I'm going to travel to Utah, and it'll go, oh, well, the first step is you should just head far north until you get to Colorado, and then drive north through Colorado. It just gives you like this linear path straight through them. Like, that was dumb, but it's not that it wasn't a smart model. It's just sometimes they make these elementary grade mistakes, which make us go, okay, model's not there. And the reality is the model can do a lot of the things that we can do now. It's a scarily large amount of the tasks that we can do, a model can achieve. And almost all the problems that it's having at the moment is it lacks feedback loops. It doesn't know when what it's doing is right or wrong, because half the time what's right is something that's in our head that we haven't explicitly called out as, I want to do exactly this. So we look at the model and say, well, that was a dumb thing to do, when the reality was that we were imprecise in our instruction. So that, and it can like if you're telling it to go a certain direction, it has no walls to bounce off. Sometimes it just goes straight off the track, which we see a lot of in coding. One of the common complaints, for example, of people using agentic coding tools is, well, I told it to fix this function. It ran the tests. The test failed. So it deleted the whole class and wrote a new one. And now it's like, oh, the tests are passing, but the commit that I've got going into my repo is massive. And that's because it kind of just went a little off track and then started, because it had no guardrail to say, no, you can't do that. It just kept going. So we do see the significant uplift in performance, and it comes at the boundaries of the task where it is actually truly hard to succeed.
Yeah, so just diving into this a little bit more, what I noticed is the exact same thing. So when I was working in my experience just with O3 when it came out, I'm not going to say O1 wasn't a revelation or like O3 Mini wasn't a revelation. But the first time I really understood that AI was getting to reasoning levels was when I saw the way that O3 was operating in the back end, because it started to give you that preview bubble that was a little bit more like, it was quick in the background. It was like really churning through thought processes. And B, the results were incredible. So do you recall the ability that, okay, for me, this ability was a revelation. It had the image that I would give it, and it would essentially figure out in 5 minutes or less where I was in the world.
Mm-hmm.
I got like it was like a weird moment where AI had reached a point to where I was actually kind of concerned. You know, it was pretty funny because like I'm Greek, so I went to a Greek fest, and like and I'm in Chicago, so it figured out where I was based off of one picture at a parade, and then it figured out I was inside a church, and like a lot of the murals in a lot of these big churches, they're not like that different, right? But in 5 minutes, figured out which one I was in both instances, and I was like, my head started to scratch, and I said it had to do a lot of cross-referencing and thinking in order to be accurate in that context. So that was the first time I saw it really push the limits. Then the other thing was I was thinking of a content strategy for like my own LinkedIn or whatever, and trying to see how it could fit relative to what I was doing in my day-to-day life as like a business owner. And it was the first time it actually came up with something from a strategic standpoint that was better than I would have thought of. Like in that time frame of that amount of time, right? I was like kind of stuck on it. And generally speaking, I do content for a living, so the AI doesn't really help me with like strategy. So, like things immediately will pop up much quicker than AI. So it was, it was cool in that sense. The image thing was disconcerting. How do you feel about this increase in reasoning and kind of where it's leading from a I don't want to say concerning standpoint, or if you have any concerns, but from kind of the context of what I just talked about.
Well, I just got a Slack message a minute and a half ago from one of my engineers who's playing with Claude 4, and he said, "This thing's fantastic. I'll see you on a beach in Bondi in 2 years because we won't have a job." and but at the same time, I would be lying if I said I wasn't concerned. Just because of the rate of change. And I've done a lot of thinking on this because part of working as a leader in AI is you have to give thought to what the societal impacts are that your tooling's going to have, because we're all in the business of accelerating the robot revolution in some way, shape, or form. And so we have to give some thought to what impact is this going to have on society. Now, we may not all act on that consideration of the impact it's going to have on society, but you have to think about it. And to me, the most concerning fact is we've been here before, but in different ways. So everyone says, "Oh, industrial revolution," all these type of things. Like those are prior waves. Computation, the accessibility of computers, these type of things. But what we miss is each one of those was automation of a specific aspect of life. So the Industrial Revolution was automation of mechanical process.
Yeah, mechanical machines, yeah.
Yeah, stamping things, building tools, like all that kind of stuff. It was automation of that. And because it was primarily physical, it had to be rolled out via a physical distribution channel. It took some time, and over that period of time, people retrained. And we got used to the fact, hey, the machines aren't there. Let's kind of ignore the work of a blacksmith because now we've got a stamping machine. That's okay, though. What we'll do now is we're going to design tons and tons of better things, and we're going to have the machines build them. And then computers came along, and the designers that were in papers was like, oh no, now this the computers are automation of process. So they're automating a sequence of things that you need to be able to do that aren't necessarily physical. It's like the automation of procedural calculation. And so we didn't have to calculate what a standard deviation is anymore. We don't need to deal with all the math when we're building a bridge. We can let the computer do a lot of that work for us. And so we thought, well, that's okay. We'll spend more and more of our time in thinking and strategizing and telling the computer what to do. Generative AI is the automation of thought. And like the revolutions before, the easiest things are the things that drop fastest. So things like, I want to write a marketing article. It's like, well, that's writing. It's creative writing. That's right in line with what this thing does. So now our LinkedIn is mostly populated with AI bots writing thought pieces on what AI bots wrote and then replying to them with AI bot summaries. So that part of it, like the automation of thought, is slightly troubling because everyone's like, oh, we'll find something else to do. Well, we gave up the doing. We gave up the procedural calculus. If we give up the thinking, where does human go from there? And more importantly, is that a skill you want to give up? Is that a skill you can afford to give up? As an example, developers that use, and Microsoft published a paper on this, I think it was in November, developers that use AI coding assistants lose the ability to write coding functions. Like if you get them and say, all right, go write a conditional loop to call this method, it takes them time. They have to go back and Google some of the stuff and pick it up. It's a muscle that they stopped exercising. And we say that's okay because you don't need to write that code anymore. The AI will write that code for you. You can spend your time thinking about how do I string the code together and how do I design the approach. In your case, this was like, how do I design the strategy for my content marketing idea or my content idea, sorry. What happens when the AI starts to intrude on that level of thought? And I'm like, oh, well, now the strategy is being designed for you by these more advanced reasoning models. The model that scares me the most is O4, not the Claude 4 or any of these other ones. The one that scares me the most is O4.
Yeah,
the reason it scares me the most is because it has the ability to use tools in its thinking process. So the flaw of the reasoning process is that the entire reasoning process is internal. Now, every LLM hallucinates. All an LLM does, in fact, is hallucinate. It's just that we find some hallucinations useful. So the thought process is a sequence of hallucination that we hope will correct itself towards the correct outcome. But since it can use tools in that hallucinatory thought process, those tools provide grounding. So it can go, oh, let me go out to the web and search for this. Let me look in the documents library and figure out what we've done before. And let me explore the real world while I'm thinking. And that, because thinking is the self-correction part of the AI's outcome process, now that it can use tools in that self-correction process, it's entirely possible that it will start to become complete in its outcome. So rather than you saying, go generate me a content strategy based on these things, you get back kind of the general vague outlines of what a content strategy should be with some specifics in there that may or may not be correct. You start to get a very specific, tailored, grounded content strategy that you're like, oh, this is what I would have written. Maybe it's even better than what I would have written. At that point, I'm starting to go, I don't think we as humans can retrain fast enough for how quickly the AI models are moving. And that worries me a little bit because if we give up the thinking ground, I don't know where we go to from there. We'll become philosophers, maybe.
Yeah. I'm in the same boat with you. I think it's interesting because I'm probably very, what's the term properly, white-pilled on it in general as to like outcomes because for society, because I'm not quite sure whether in history we've ever been able to accurately predict the outcome, right, of these things. Like for example, when ATMs came out, the one example I always use is that actually there was a decentralization of banks, so then we actually got more bank tellers, which is funny. So our prediction's usually pretty bad on this stuff. So I'll just hopefully be optimistic, right?
Then why are tech companies laying off developers?
Well, yeah. Maybe because the AI is predicting it for them. Maybe my term "we" only applied to humans before. Now the reasoning models are doing a better job. But it's interesting. I think that what you're pointing out with the thinking is definitely my concern as well, because I noticed with O3 that it was starting to use things in the background, and then like you said with O4, it has tools as a base. So when it comes down to it, all accessible advice on a public spectrum, if it is truly capable of having access to it. Like I remember mentioning this, like it's on record on the podcast like 3-4 months ago. I was like, the limitation of these LLMs is actually not necessarily at the moment directly correlative to how much data it's trained on. It's the fact that it's limited to its own boundaries of information, right? And once we start having it native to the model, like you're saying with O4, to where it has tool access, I'd imagine, by the time we get to the O5 realm of things, it is essentially a self-learning situation where it just has the ability to access all resources that are public knowledge and then continuously do that in a loop until it has reached peak marketing guy or peak in a niche,
So I'll tell you what, and and Anthropic and OpenAI, if you're listening, the model that would convince me that it is now ready to replace humans more generally is the tool using recursive model, because there are two limitations. There are two limitations to AI. One limitation is access to information. The other limitation is context width, how much information it can hold in its mind at any given time. And it's demonstrable that if you give it more context, it becomes more distracted. So a lot of what AI systems engineers, which is realistically what my role is I design systems that use AI. We don't train the AIs anymore because, if we trained 3.7 of Claude, then 4 comes out, chances are it's better than what we trained into 3.7. So we're just kind of like, don't waste your time there. But the reason that there is still work for AI systems engineers is because the models themselves are kind of unary, if that makes sense. Like it tries to complete the whole task itself. And if the task is sufficiently large, then it will get distracted along the way. It'll go down part of it. It'll complete part of the task. It'll say, I'm done when it's not done. We've been able to prove with our agentic approaches that if you can correctly break those tasks down and systematically contain them so that each one has like a clear definition of input and output, everyone has some validation metrics. It's got access to only the suitable tools, because just giving it all the tools is a really bad idea. It gets kind of distracted as to which ones to use. If you go down that path, you can break down big complex problems into very, very well constructed solutions. It's not perfect with the current models because the linkage between those is externalized. It's not part of the model's reasoning context. It means that it needs humans to kind of guide it between those. But the model that I'm convinced would replace that entire solution is the model that could recurse a task onto itself and say, I'm giving me a task, I'm going to pause my prior context and I'm going to use this new context. If you trained that technique into a model, then it would become exceptional at breaking down work and determining input and output criteria for that work, which makes a whole AI system redundant. And that model would actually be able to cure its own illness in that it could account for its own context length. I believe at that point it wouldn't actually need to learn because it could just delegate work down to the point where access to the information in the tools and the ability to reason and read would be enough for it to be able to achieve most goals. So that's the model architecture I think is probably going to appear, and I think it's happening next year.
Wow. And when that happens, seems like we're in the mood for predicting. What do you think?
Beach in
that
Bondi.
means? What'd you say? What'd you think?
I said beach in Bondi.
Beach in Bondi? Heck yeah. That'd be fun.
I think we will find out whether we can pay that bill, right, both in terms of energy and computation cost. And I think the only limiter at that point will be trust. So
okay.
We trust other people more than we should, and we certainly trust them more than AI. And a part of that trust is because we have mechanisms to recoup loss. So like if you are my Uber driver and you run off the road, then I can recoup that loss from you through the court system. Assuming I'm still alive, otherwise my family can. If you are an AI and you run off the road, then in theory, the company that made you is responsible for that, and me or my family can recoup that loss from the company that made you. But the problem is that all these companies are putting the self-driving terms into their terms and conditions, which is the human that is using the AI is responsible for the AI's actions. In other words, you have to be behind the wheel. The problem there is we're going to reach the point where we can't actually meaningfully review the work of the AI. We're already kind of there if you use agentic coding and it's writing code. Sometimes it's almost impossible to keep up with what the AI is doing and to review if it's correct or not. So given that fact, it becomes unreasonable to be expected to review it. So either the company just accepts the responsibility for it, or we go down one of two paths. One path is we say, all right, well, you just can't use AI for that use case because it's too high risk. The other path is we as a society allow for algorithmic error. So I say it's acceptable that the AI is sometimes wrong because it's safer than humans in the same context. So if it's wrong, tough bananas, here you go. I don't think we can go down that path because it opens an avenue for AI developers to effectively abrogate responsibility. So I think that the only thing that will be holding back in the year of the recursive model, whenever that comes out, will be society's willingness to allow it to do its work.
Interesting. Okay. So then what does this necessarily mean, I guess, in the context of for you, right? Like with what you guys are doing specific, not you individually, right? So we're talking about a lot of, it's funny. I feel like we didn't really spend much time. We're actually getting decently close to amount of time on that podcast, but we didn't really talk about you guys, right? Like you as Tricentis, what does this mean for you?
The easiest way to think about it is AI uses tools. AI is the brain. It's not the hammer, if you will. So imagine AI
I agree.
If Google didn't exist, how good would AI be at searching the web? Well, be complete rubbish because they would have to use Bing, and who knows what you would get back at that point.
Complete rubbish, yeah.
So sorry, Microsoft. I know whoever our Microsoft rep is.
No, you don't never have to apologize. A company with that many billions of dollars being that bad does not deserve an apology.
Yeah, that is true. But our bet in Tricentis is we had the best tools before AI came out for achieving the goal. So AI is just going to make those tools work for more people.
Better. Okay.
So our whole goal right now is just how do we get those tools in the hands of the most people and the most AIs possible? Like
You're just taking that. It's basically taking your tools and you're essentially giving it to a better craftsman.
Exactly.
Okay. Good.
Yeah. And so that's how we view like the future of AI and Tricentis is we are carving out a niche for ourselves in that we want to have an out of the box craftsman for you where you engage with it and you say, all right, I want you to use the tools for me. I want an agent that is going to, look at a requirement and completely break it down into exactly the scenarios that need to be run, that picks up my own enterprise knowledge, that can cover every aspect of that and can prove that it can cover every aspect of that. And that's a niche for us because when I look at any work in AI, I split it into two categories. There's interesting things that we need to do to solve our customers' problems, but there are also things that everyone else needs to do, right? So this could be, how do I map knowledge and create a graph out of that knowledge? Like we need this because there's a ton of organizational knowledge that we have to map and graph in order to make this work. But that's not a problem related to testing and related to QA. That's a general problem. So we ignore those problems until a solution appears because guarantees someone's working on it. The other set of problems are problems that we need to use AI for that are related to testing. So a very good example is like you got a requirement, you got a bunch of requirements. One, how do you break that down in a systematic way so that you can prove you've got good coverage of the requirement? And two, how do you prove that traceability so that someone can eyeball it quickly and go, yep, that works for me, and just approve it without having to read everything? Because the moment you make someone read the entire output of the AI, you kill about 3/4 of the potential productivity because we're really slow readers. So everything should be about trying to get away from the reading, let the AI write, let you edit. And so that traceability is where we see some unique value out of us in the AI game. But the foundational value, the thing that's going to help us, stay relevant in the long term, is really just that our tools are going to be the best tools on the market because they already are, and we're dumping a ton of money into making sure they stay that way. And that's advice that I give to sort of the startups out there, the people that are looking at an AI startup, telling them AI won't be your differentiator. We know because you're using the same AI everyone else is. You can't turn that into a differentiator and we say, we're using Claude 4 like everyone. So what is your differentiator? It's either the tools, it's your IP, or it's your user experience. Tools is a durable differentiator. IP is a transient differentiator. And user experience is a temporary differentiator because everyone's going to be able to copy that. So that's the advice we give. It's also what our path is in Tricentis. And I don't know if there's a company pitch here. Hey, go visit our website. We do really cool stuff. It's tricentis.com. And occasionally I publish blogs there, which are super nerdy related to AI and how we go about building agents and stuff. So you're welcome.
I didn't even have to tell you to plug it. That was awesome.
There you go. I'm all over this.
No, I really appreciate it. It was kind of a fun chat just about the future of AI, and I feel like a lot of people probably learned a little bit more about how they necessarily work and the history of how we got to where we're at. So we really do appreciate you for taking the time here with us today. Like he said, make sure to go to Tricentis, this website at tricentis.com in order to check them out. Remember, they're tools, and the improved models are essentially just better craftsmen to help their tools work. With that being said, thank you so much for listening to this episode of the AI Agents Podcast, and we'll see you in the next one. Bye.
Bye.